Hi guys, today's video we are going to do the packet tracer, identify MAC and IP addresses. So the objective of this activity is to gather VDU information, and the part 2 is reflection question. So the background of this activity is optimized for viewing PDUs. The device are already configured. You will gather VDU information in simulation mode and answer a series of questions about the data you collected. So, the part 1, gathered PDU information. So, review the reflection question in part 2 before proceeding with part 1. It will give you an idea of the type of information you will need to gather. So, let's start. So, step 1, gathered PDU information as a packet travels from 172.16.31.2 to 10.10.10.13. So, we're going to click this one, and we're going to command prompt, which is this one. And we're going to ping the IP address of the PC. So we're going to ping, sorry. So we're going to ping 10.10.10.3. Then, okay, it requests the reply. And then we're going to switch in the um we're going to switch in the simulation mode, which is this one. So as you can see, we have now a simulation panel. So excuse me. So we're going to repeat the ping. Um, wait, we're going uh, to adjust this. Then we're going to do the ping again. 10.10.10.3. And as you can see, we have gathered data in the simulation panel, which is this one. So the next step will be click the PDU and note the following information from the outbound layer tab. So this one, let's minimize this, and we're going to, okay. So the destination MAC address, we're going to the outbound PDU layer, and the destination MAC address will be this one. So our destination MAC address is the same. Then the source MAC address, this one. Excuse me. So it also the same. Then the source IP address is this one, and the destination MAC address are this one. So what the device computer. So click capture forward to move the PDU to the next device. Gather the same information from step 1. Repeat this process until the PDU reaches low. So we're going this to hub. Okay, we know this for the hub. And then we have now for the switch one. Okay, and then for the switch one, and then the router one, Anyway, we have the information gathered, and the switch zero. Okay, then the access point, and then the next one is the 10 point. Alright. Now that we have gathered additional PDU information from the other ping, repeat the step 1 and gather the information for the following test. So ping 10.10.2 from 10.10.3. So we're going to ping this one, desktop, then command prompt, then ping the 10.10.10.3. Excuse me. So now let's wait for the reply of the. So it's pinging, and then we're going to. So let's try for the another one. So 172.31.2 from this one. So let's try. So it's also pinging for the 3.3, and the request timeout. The ping succeed. Okay, it's successful. Then let's go um for this one to 10.2. So as you can see, it's now replied that. So it's now that we had the connection to the 10.10.3. We have no connection for that. So you're going to do the ping again to test if you have a connection to all the PC that you had in this topology. So that's the purpose of why you ping and why you do the command ping to test the connection for the other PC. So now that we had done this one, it's probably it's all done with all the other PC. So let's move forward for the reflection question. So answer the following questions regarding the capture data. So were the different types of wire used to connect devices? So we have two. Yes, we have the copper and the fiber. So number two, did the wire change the handling of the PDU in any way? So the answer will be no. Then number three, did the hub lose any information given to it? So probably no again. So number four, what does the hub do with MAC addresses and IP addresses? So um the the hub do with MAC addresses and IP addresses is do nothing. Um, so let's move on for the question number 5. Did the wireless access point do anything with the information given to it? So the answer is yes. It's repackage it as wireless at 8.02.11. So number 6, was any MAC or IP address lost during the wireless transfer? So the answer will probably no, because it's not loose during the wireless transfer for the MAC address or IP address. So number 7, what is the highest OS layer at that the hub and the access point use? So the highest layer that the hub and access point use is the layer 1. Excuse me. So question number 8, did the hub or access point ever replicate a PDU that was rejected with a red X? So the answer will be yes. Then let's proceed for number 9. When examine the PDU details tab, with which MAC um which MAC address first the source of the destination? So the answer will be that for that question is the destination. So why would the MAC addresses appear in this order? So um the answer for that is a switch can begin forwarding a frame to a known MAC address, not address more quickly if the destination is listed first. So was there a pattern to MAC addresses in the simulation? So no. And then did the switches ever replicate a PDU that was rejected with the red? So it the same question for the 8. The answer will probably no. Then number 13. Every time that the PDU was sent between the 10 network and the 172 network, there was a point where the MAC address suddenly changed. Where did that occur? So it occurred at the router. So 14. Which devices use MAC addresses starting with the 00D? So it, um um the device use MAC address starting with the 00DO is the router. So, to what device did the other MAC addresses belong? To the sender and to the receiver. So, did the sending and receiving Internet Protocol version for addresses who switch on any the PDUs? So, no. 16, did sending and receiving IP addresses switch in any of the PDUs? So, that probably will be no. And then 17, if you follow the reply to a ping, sometimes called the pong, do the sending and receiving IP address switch. So yes, as you can see a while ago, it sending and receiving Internet Protocol addresses switch because it reply, as you can see on the screen a while ago. So number 18, what is the pattern to the IBP for addressing in this simulation? So the answer is each port of a router requires a set of non-overlapping addresses. So number 19, why do different IP network need to be assigned to different port of a router? So the answer will be the function of a router to interconnect different IP networks. So last question for this packet tracer activity is, if this assimilation was configured with the Internet Protocol version 6 instead of IPv4 or Internet Protocol version 4, what would be the difference? So the IPv4 or Internet Protocol version 4 addresses would be replaced with IPv6 or Internet Protocol version 6 addresses, but everything else would be the same. So it will change the Internet Protocol version, but everything else would be the same. So it's the same even if you change the Internet Protocol version 4 to Internet Protocol version 6. So now guys, that we had done in this activity, or and then we have we have did all the requirements to finish this activity. Hope you guys learn something about this video and hope you guys that it help you to pass the CCNA activity. So thank you for watching and lend me sometimes. Thank you.